Now let us see the problems related with the marginal function, probability distribution function, probability density function. Okay, let x and y be the continuous random variable with the joint density function f of x comma y is equal to e power minus y over the range of x defined for 0 to y and 0 otherwise. Find the marginal density function f of x and f of y. Now, what is given in the question first we'll analyze. The given in the question is for the two variables, that is x and y. Okay, and the limits that are given for x is from 0 to y. Okay, now within this we'll be able to see the limits for both x as well as both y. How we shall we see? We already know that the formula is integration from minus infinity to plus infinity, integration from minus infinity to plus infinity, f of x dx dy is equal to 1. Over here at the down you can write capital X capital Y also. Even if you don't write, it's okay. Okay, now what is x range? X range is given from where? From 0 to y. Okay, and what is the range of y? The range of y will be automatically from the range of y will be with respect to x, where x is nothing but equal less than y. So the range automatically for y will be from 0 to infinity. Now we'll put the values in the formula. So integration from 0 to y, this is the limit for which one? For the x. From 0 to infinity is the limits for y. What is e power y? The function which is given in the question, e power minus y dx dy. Now let us just split it to make it easy. With respect to x, what are the limits? 0 to y dx. With respect to y, over here I have e power minus y dy with the limit 0 to infinity. Let me first do the integration for the case of this one. If I integrate dx, I'll be getting as x over the limits what? 0 to y. So 0 to y. I'm keeping this function as it is, that is e power minus y dy. My limits of this particular from 0 to infinity, I have written it over here. Now if I substitute the upper limit, I'll be getting as y. Lower limit is anyway 0, so no issues. So this will become as y e power minus y dy. Now this function I have to solve. Okay, this is UV method. So how do I solve? First function, that is y as it is, then second function I should do the integration of it. If I integrate, what I'll be getting? I'll be getting as e power minus y divided by minus 1 over the limits 0 to infinity minus integral differentiation of y will give me the value of 1, and integration within it will be there. So integration of e power minus y is e power minus y by minus 1 into dy. Okay, now next thing is I'll substitute the limits. If I substitute the limits for the function, just see it once again over here. My first limit is, see, I'm putting the cursor down, means it is not to be shown. So if I put the limits of infinity over here, automatically my function will go off, so nothing will come infinity. Even if I put 0, since it is y is there, 0 into anything is 0, minus over here the limits. See, if I substitute my limits over here, infinity and 0, e power infinity minus e power 0. Okay, y into e power of 0 is anyway 0, minus over here still I have to integrate. E power minus infinity will fetch me what? E power minus, sorry, over here if I substitute the upper limit as infinity, I'll be getting as infinity e power minus infinity. Okay, minus, if I substitute the lower limit 0, it will be 0 into e power minus 0, that is anyway 0, minus over here still I have to integrate. So I'll be getting as what? E power minus infinity integration once again will give me e power minus infinity. This minus and that minus will become as plus. Okay, so I'll be getting the values over here as e power minus infinity and 0, plus over here I have solved e power minus infinity minus 1 over the limit 0 to infinity. How this plus has come? Over there we got we had minus outside and one more minus, so it has become plus. Now I'm substituting this value. Anyway, this value has gone off, it is no value. Now I'm substituting the upper limit, so it is e power minus infinity, lower limit is e power 0 divided by minus 1. So e power minus infinity is undefined, or it is 0, minus e power 0 is 1. This denominator is as it is minus 1, so it is equal to 1. Hence the function f of x comma y hence the function f of x comma y is equal to e power y is a continuous random variable. Why we are saying it as a continuous random variable? Since whenever we are taking integration of the function, it should fetch the answer as 1. Hence it is proved. Now the second bit says to find the marginal function of x. How do we find the marginal function of x? The formula is f of x is equal to integral y f of x comma y xy dx dy. When we are taking the marginal function of x, my integration is with respect to y. Now what is f of x comma y given? It is given in the question as e power minus y. What is the limit of y? My limit of y is from x to infinity. Okay, or I can write as from 0 to infinity. Let us first write from x to infinity. Okay, so now e power minus y integral, when we do it, I'll be getting as e power minus y divided by minus 1 over the limits x to infinity. If I substitute the upper limit, I'll be getting as e power minus infinity minus e power minus x divided by minus 1. Now e power minus infinity is anywhere invalid. The numerator minus and this denominator minus will become a plus. What is left of the function? F of x is e power x. Okay, this we got for the marginal function of x. Similarly, the marginal function of y. What is the formula? The marginal function of y is given as f of y is equal to integral with respect to x f of x comma y dx dy. Now when I am doing for y, I need to take the integral for x. So f of y is equal to integral. What is the limit of x? We've already seen the range of x is what? From 0 to y, e power minus y dx, right? With respect to x, we have to write over here. Now integral of e power minus y is now constant. Why it is constant? Because we are doing the integration with respect to x. Hence the values that are associated with y will be constant and it is taken outside. So what is the equation now? Integration 0 to infinity dx. Okay, now if I do the integration of dx, what I'll be getting? X over the limit what? 0 to y, and e power minus y is anyway as it is. Now when I substitute the value of limits of this value, that is upper limit and lower limit, I'll be getting y minus 0, e power minus y into y minus 0. So what is my function? F of y is y e power minus y. Hence I got both the values of marginal function of x, marginal function of y, and I have also found what is the continuous random variable. So the three things that has asked in the question is, one is find the marginal function, density function f of x, f of y. And in order to find f of x and f of y, we should see that whether this function is continuous or not. So for it to be continuous, it should be equal to 1. That we have got it. Next step we should do for f of x. Next step we should do for f of y.